Welcome to all. Hello, dear students. I am Sagar Avvade, working as a lecturer in Mechanical Engineering Department, CSMSS College of Polytechnic, Aurangabad. Today, this is first lecture on topic simple stress and strain. After watching this video, you will be able to know about stress, strain, and types of stresses and strain. The basic terms that you have already studied in engineering mechanics. Equilibrium. Any system of force which keeps the body at rest is said to be in equilibrium. Conditions for equilibrium are summation of f of x is equal to 0, that is, algebraic sum of all the horizontal forces must be equal to 0. Summation of f of y, that is, algebraic sum of all the vertical forces must be equal to 0. Summation of m is equal to 0, that is, algebraic sum of moment of all the forces about any point must be equal to 0. Rigid body, a body which does not undergo any deformation when subjected to an external force is known as rigid body. In engineering practices, there is no perfectly rigid body. Deformable body. When the external force is applied on body, then the body will get deformed is known as deformable body. Load and types of load. Load. The external force is applied on body are called as load. Types of load or force. Tensile force. When the force is act away from the point of application is called as tensile force or pull force. Here the diagram for pull force. Compressive force. The force is act towards the point of application is called as compressive force or push force, which is shown in figure. Shear force. The force which is act as parallel or tangential to the plane under consideration is called as shear force, which is shown in figure. Stress. Dear students, as we know that when we apply the external load on body, then body will get deformed. That means deformation will take place. This deformation is of two types. One is elastic deformation and another is plastic deformation. This deformation is resisted by internal resistive force developed inside the body, which is shown in figure. Here the pull force is applied on body and the cut section is taken. In this diagram, the pull force is applied on a body, and here these are the internal resistive force developed inside the body to resist the deformation of body. Similarly, in this cut section is also. So, the stress is defined as the internal resisting force is developed in a body per unit cross-sectional area is called as stress. The stress is denoted by a symbol sigma. Therefore, sigma is equal to internal resistive force upon cross-sectional area. Therefore, sigma is equal to R upon A, where R is internal resistive force, A is cross-sectional area. But internal resistive force is equal to external load P. Therefore, sigma is equal to P by A, where P is load acting on body and A cross-sectional area of body. Therefore, mathematical definition is, it is defined as force per unit cross-sectional area. The unit for stress is Newton per meter square, where the unit of load is Newton and unit of area is meter square. So the unit is Newton per meter square. It is also called as Pascal. It is denoted as PA. Therefore, 1 Pascal is equal to 1 Newton per meter square. Here, some other units are given in numerical like kPa, kilopascal means 10 to power 3, megapascal 10 to power 6, GPa, gigapascal 10 to power 9. Conversion which is required for numericals. 1 kPa is equal to 10 to power 3 Pascal, that is 10 to power 3 Newton per meter square. 1 megapascal is equal to 10 to power 6, that is 10 to power 6 Newton per meter square. Here Newton per meter square is converted into Newton per mm square. So we know that 1 meter is equal to 1000 mm and 1 meter square is equal to 10 to power 6 mm square. Therefore, 10 to power 6 Newton divided by 10 to power 6 mm square. Now 10 to power 6 get cancelled. Therefore, 1 MPa is equal to 1 Newton per mm square. Similarly, 1 GPa is equal to 10 to power 9 Pascal, that is 10 raised to 9 Newton per meter square. This Newton per meter square is converted into Newton per mm square. So 10 to power 9 Newton divided by 10 raised to power 6 mm square. Therefore, 1 GPa is equal to 10 to power 3 Newton per mm square. Strain. It is the ratio of change in length to the original length. Here, pull force is acting on a body. This is original length L, and when we apply the pull force on body, then body will get elongate, and this elongation is denoted by delta L. So total length of body is L plus delta L when we apply pull force on body. Here the push force is applied on body, then this total length is reduced by delta L. So the total length is L minus delta L. That means this is the total length, where L is original length, delta L is change in length. It is denoted by epsilon E. Therefore, E is equal to delta L upon L. It has no unit because it has the ratio of same quantities. Types of stresses and strains. Tensile stress and strain. When two equal and opposite pull forces is applied on body, then body will get elongate. The body is said to be under tension, and the stress is induced in it is called as tensile stress, and corresponding strain is called as tensile strain. Here in this diagram, pull force is acting on a body. This is the original length of body, and when we apply the pull force, then body will get elongate, by delta L. So the total length is L plus delta L. This is total length. Compressive stress and strain. When two equal and opposite push force is applied on body, then body will get shortened. The body is said to be under compression and the stress is induced in it is called as compressive stress, and corresponding strain is called as compressive strain. Here in this diagram, the P is push force is acting on body, where L is the total length of body, and when we apply the push force on body, then body will get shortened by delta L. So the total length is this, that is L minus delta L. Shear stress and strain. When two equal and opposite forces acting tangentially to the section to slide its one part over another at that section, the body is said to be state of shear. The stress is induced in it called as shear stress, and corresponding strain is called as shear strain. Here there are two plates. These two plates are joined with the help of this rivet and this P, that is tangential force acting on that section. After that, when we apply the tangential force on the body, then this rivet will shear off. Here the shearing is take place.